I will tell you about the data set, then we'll move forward. Okay, it is the very familiar data set to us. I have been giving example on this since my first class. Okay, so first of all, line 1, I inputted the functions like numpy as np, pandas as pd, matplotlib.pyplot as the plt. Okay, and as I told you, the fourth line of code is specific to only to the Jupyter notebook. Okay, because matplotlib in line, it will put the graphs into a correct alignment inside the Jupyter notebook. Okay, and I am importing a package of matplotlib, that is C1 as SNS. Why as np as pd, is that fixed or I can change it? It's not fixed. You are giving alias name here. Simply for the package you can give your name, but yeah, the whole of industry follows the same norm. We do it np pd sns because it would be easy, like as of now you are working with a company and tomorrow you left that company, so whosoever will come to that position, he will quickly grasp it by going through your codes, like what you have developed. Okay, so it's better to follow the same norm. These five line of commands which are very familiar to us by now: numpy, pandas, matplotlib, and c1. So moving forward, I will explain the data set. Okay, it's a bank personal loan modeling data set. What is that bank personal loan modeling? Here, if you see, if I do the data.shape, it is showing me that my data is having 5,000 rows and 14 columns, means features, attributes. Okay, we call the columns as the features and attributes. So in that 14, one must be the target column. That is the, if you see, that is the personal loan column. These are the records for each of the customer. Each customer, there are 14 attributes the bank has given in the data set. What are those? ID. ID is nothing but a unique number, okay, or a primary key. Key is nothing but the ID. Next one is age, obviously for each person. And next one is the years of experience the person is having. Okay, and the next one is income in thousands. Okay, what's the zip code for that person in his residential? The family, what's the family size? Okay, and what is cc average? Cc average is the credit card average. Okay, next one is education. In the education, it's I think 1 2 3. 1 means it's already been coded here, otherwise it should be like undergraduate, graduate, and postgraduate. Okay, 1 2 3. And next is mortgage, whether that person is having any loan with the bank. Okay, and this column, the personal loan, is your target column. The bank wants to find like whether the person will take the loan or not. Okay, now it is, the question is whether the person will purchase the loan or not, or same way it can be whether the bank can sell the loan or not. What is the securities account? Means that person is having the security account with the bank or not. Okay, this is the CD account. CD is current demat account. And online, whether that person is using online banking or not, and whether the person is having credit card or not. You might be thinking, like for the education, it's like 1 2 3. The computer will see that 2 is greater than 1 and 3 is greater than 2. Okay, why not we make it into all to the same level? Okay, like previously with the one hot coding, we have changed it 1 2 3 in 3 columns. We divided, so wherever it's undergraduate, it's 1 raised to a 0. Wherever it's graduate, that column is 1, other two are 0. What I mean to say, another possibility is that you can divide this one column because it's having three values, right? 1, 2, 3, graduate, undergraduate, and postgraduate, three values. So you can divide it, this one column, into three columns. Okay. So one is undergraduate, graduate, then postgraduate. Suppose this person is 1. For the record, index 0, the person is undergraduate. Okay. Assume that this column is not there entirely. You have, instead of that, you are having 3 column. Okay, that means you have added another 2 column, that is undergraduate, graduate, and postgraduate. So actually 0 is undergraduate. So what will happen for that column? Means for this person, record 0, the undergraduate column will be 1, and the graduate and the postgraduate column will be 0, 1, 0, 0. Okay, when the data is given in a string format, okay, like it is written not 0, 1 but in string. Okay, so what it is called, suppose there are three values. Okay, graduate, one is undergraduate, another one is graduate, another one is postgraduate. Okay, now all three are combined into a column called education. Okay, so what will happen, we call it one hot encoding. What it will do when we use a package one hot encoding, okay, it will take this column, that E column which is existing, and it will divide into two. What it will do, instead of you will get a column called E, education, you will get undergraduate, graduate, sorry, and postgraduate. Okay, assume these are the all the other, these are the rows, and these are the other columns already existing, like ID, A's, and all. Okay, so for the record 0, okay, 1, 2, like that, for 5000 record it will go. So for the record 0, and we are coding it such a way, undergraduate is 1, graduate is 2, postgraduate is 3. So for the 0 index, the person is education is 1. Okay, that means what it will do, it will keep the 1 here. Okay, rest is 0. Now I have come to 3, record number 3, means index 3. That person is 2. Okay, so that means what it will, record 3, right? For record 1, for record 1 and 2, it's same. Okay, 1, 1, 1. Okay, so it will be 1, 0, 0. 2 is also undergraduate, 1, 0, 0. And now come to record number 3. 3 is 2. Okay, means that person is a graduate person. So it will code as 0, 1, 0. This is called label encoding, LABEL, one hot label encoding. It is used when you are given a string. Okay, suppose you have given strings like undergraduate, graduate, and postgraduate, not 1, 2, 3 in your data set. So to change within a column, within a single column, okay, the data is given, because nobody is going to give you one hot level. Your customer is giving, then you are very, very fortunate, he has lot of time in the world. Okay, but none of your customers will have that much time. Okay, so they will give you data entered to the system by a data operator. There are a lot of mistakes, and they will try to do as small as possible so that they can operate very quickly. In this case, you will, under one column, if you have string values like undergraduate, graduate, postgraduate, then change it to the format that is understandable by the system. You do one hot encoding. Okay, once you do the one hot level encoding, it will give you that all those values are equal. Okay, because wherever it's 1 and other are 0, that means it is giving that value for that column. So it is not like that undergraduate is less than graduate and less than postgraduate. it is not that, it will not assume in that way. It will say that all the features, means all these three U, G, P are equal. For example, if you see that if it is a data set of automobile car manufacturing, and it is mentioned that three countries are there as a car origin. One is USA, suppose, assume, one is Japan, and one is South Korea. Okay, so there are three countries are there with this. So there is no way you can say USA is greater than Japan, okay, and it's greater than South Korea or any of the order. You cannot say. This concept is wrong. It doesn't matter, right, where the car is origined or manufactured. So for that, to make all these three are equal, we do the one-hot encoding. Once you do the one-hot encoding, the computer will understand US equal to Japan, okay, equal to South Korea. The value for the data set will be like this. But in our case here, in education, obviously, the person who is undergraduate, he is less than the graduate in knowledge wise, in the education wise, and he is, this graduate person is less than the postgraduate person. Okay. There is, in our case, there is no requirement of making these three fields equal, because obviously the hierarchy exists for the undergraduate, graduate, and postgraduate. So that's why we can do, instead of going with one hot level encoding, we can only encode U to 1, G to 2, and postgraduate to 3. If you encode simply that these two, you replace, the code is undergraduate, replace 1. Okay. So once you use the replace, so wherever the undergraduate is there, it will be replaced by 1, graduate with 2, postgraduate with 3. And the system will understand 1 is obviously less than 2 and less than 3. So our purpose is satisfied here. You have to decide whether you want to go with simply converting it to the integer value, like a hierarchical value 1, 2, 3, or you want a one hot level encoding. If you do the head, you will get only 5 columns, 5 rows, 5 records. If you specify a number, you will get that number. I told you you have to do HIND, H for head. Okay. Next, info. Once you do the info, what will you get? You will get all the column details, the feature details. Okay. If you see, it is mentioned data columns, total 14 columns, range index from 5000 entries, 0 to 499. For each column, what's the value? Like these are the 5000 records for all. That means by seeing it, you will come to know there is no null value. If it is null value, missing value, it will be less than 5000 for that respective column or feature. And all of the columns are either integer or float. So HIN, N is for null, check the null, data dot is null dot values dot any. Okay, so as I told you, if you remove that any or values, still you will get it, but it will be very tedious format. Just see. Okay, I am removing values dot any, you will get it is null. See, for the whole record you will get it. Okay, from 0 to 499 you will get it. Okay, so it's very difficult, like you have to see where the true is there. Okay, so that's why we do it dot values dot any, you will get directly one word. If it is there, it will show you true. Then you can go and check it where it is, where is the true. Next, HIN, and the fourth one is D. I have just transposed it. Okay, if you don't want, it will be like this. Okay, so for the visibility purpose, I have changed the row to column and column to row with dot T. Okay, so if you see, the count, mean, standard deviation, minimum value, 25 percentile, 50 percentile. 50 percentile is the mid value. If you arrange the data from in a ascending order or descending order, what is the mid value for the data? Okay, and what is the maximum 75 percentile maximum value for the data? Likewise, for each of the features, it's there. Count for all 5,000. What's the mean for all? Like for income, it is 73K is the mean. Okay, the average value, all the values into count for the experience. 1 plus 14 plus 15 plus 9 plus 8, like that for 5,000, and you have divided by 5,000. Okay, likewise standard deviation, what's the minimum value, what's the maximum value, like that it's there. So once you describe something, you have to mention there. From the above description, it is clear that most of the attributes don't contain the outlier. Okay, when you plot your data, okay, suppose this is the x-axis and y-axis. Okay, I am giving only two axes because you can visualize the data in two-dimensional. Here, this I cannot plot it because there are 14 dimension, 14 attributes. Okay, so only the human eye can see the two dimension, or at best the three dimension. So these are the x values. Okay, these are the dependent y values. Suppose you take it experience and salary. This is experience, okay, independent, and your salary is depend on this. Okay, salary. For this person, the salary is this one. For this person, this one. Okay, this one, this one. Okay, these are the points. You have given experience equal to, you name it, 1, 2, 3 years, like that, and you mention it whatever you want, 10K, okay, 20K, like this. So you find all, most of your data points are in a cluster way, okay, in your data set. But you find some of the points are in this way. Okay, it's here. These all belong to one group and these all belong to the other group, and the majority lies here. What could be one of the examples? These are the normal employees, and these persons in the higher salary bandwidth, maybe the management like CEO, CO, okay, CTO, like that. So when the outlier concept tells us that those persons are outliers to this data set, they drag the mean, okay, more towards them because they are having high bandwidth, okay, they are into the higher region, and they tries to change the shape of the data set when you do the mean, okay, when you do the standard deviation. What will happen? Obviously, because they are into the high zone, they will try to drag the mean to this, because for those guys the mean is almost here, right? All are into the same position. Okay, but when you add those data values, the mean will be shifted to here. Okay, because the number is less, the value is more, obviously the mean will shift to their side. So the outlier concept is that those persons should be excluded. Okay, I'm clearly saying every time you have to do the data outlier treatment also, should be excluded, okay, from the data set if it's not that much relevant. Okay, the call has to be taken by you. You can drop those rows. Okay, excluded means you remove those fields, means those records from the database, or you replace those values with the mean value or median value of this data set. There are two ways. One is exclude or impute. Okay, impute or replace. We call it impute. Okay, impute or replace those values, the outliers, with the mean of the group or standard deviation of the group, or it's, if suppose it's a string, then by mode. So if you see I'm not doing any great thing here. You need to give one command, sns dot box plot. Okay, what you want to plot? You want to plot the income attribute of data. Data is my data set. Okay, I have made a data frame named data. Data is my name given by me. In this data, I want to plot which column? Suppose income column. Okay, I want to plot it. So that's what this code line of code is doing. SNS, that is Seaborn. Box plot is the function. What I want to plot? I want to plot income column. Okay, income feature of which data set? Data. Okay, so this line of code gives you the picture. Why it is important? Why I am saying that use Seaborn? Because if you see a tail here, right? It's all the values dot 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 dot. Those are the outliers. You can say directly to this attribute. So if you see, look, the box plot data experience, that means you want to plot the experience column, this column, experience column, you want to plot it. Okay, you have taken to see whether the outlier exists or not. You see here, you have plotted data experience, there is no outlier. Okay, whenever the outlier is there, it will come like this. Okay, those are the outlier points. That means they are not in the cluster. Those points, outlier points. Okay, so that's why we use the box plot to see the presence of outliers. Okay, so we'll proceed with the outlier treatment, and the next is per column. I want to find it, the histogram. It's not required. Okay, it's for a small data set, it's not required. We will have a class on the Seaborn. Then I can tell you like how to plot these figures and what's the feature. At least as of now, you remember one, that is box plot. sns.boxplot. It's going to be useful for the outlier identification. Okay, and pair plot. Pair plot is the pictorial view of this, heat map. We call it the feature. The entire feature is called EDA. Whenever somebody is saying, okay, have you done the EDA? EDA. Okay, it means exploratory data analysis. This is E for exploratory, D for data, A for analysis. That is what's the data given to you. You have to go through that. Okay, you have to explore that, and you prepare for the pre-processing. All that comes under EDA. Line number 16. What I am doing? I am dropping certain columns. Okay, I have given data.drop, and the column names I have given ID, zip code, personal loan, and axis equal to 1. You remember I told you axis 1 means the entire column will be dropped. Okay, so what columns or features I am dropping? Attributes ID, zip code, personal loan. Why? There is no significance of ID for the data, right? For building model, ID is nothing but an index, 1 2 3 like that. Okay, so obviously you don't need an index for the data set, so I'm dropping it. Likewise, zip code, it doesn't matter like that person is where he is residing. If he is paying or willing to take the loan, it's okay for the bank. So this decision has to be taken by you. Okay, I am again and again saying that this decision has to be taken by you. Okay, what all the columns you want to drop it, what you feel in the data set, it's not relevant. And the third one I am dropping here is the personal loan. Why I drop it? Because I will put it in the Y. Y is my target, right? X is my attributes, features. So I have dropped from X, I put it in Y. So I have prepared my X and Y data set. How the X values are correlated with Y. So what it gives, that the dependency among X and Y. Okay, that value it's giving here. High dependency, that means there is a high correlation between them. If you see, as with the Y's are what? The target, the personal loan, very less, 0.00, that means around 0.7%. Experience same. But if you see, you come to income, the third one. What's the correlation? 0.5. Okay, that means 50% correlation between them. Okay, so that means if income changes, then obviously the personal loan means your Y changes. Okay, and the change is around 50%. Likewise, you see the credit card average, CC average, it's 36% between X and Y, the correlation. The interpretation is how the X is related to Y. Okay, so if X changes, what will happen to Y? In age, even though X changes, there is no much relation, right? Because it's 0.00 correlation. So it will give you some idea like which are your features are useful, are very important for you. Okay, so that you should not delete them. Okay, line number 19. I think it's very much familiar. Last class also we have discussed. When your X and Y are ready, now you try to start modeling. Before that, you have to divide your data into 80-20, 70-30 like this. 70% training and 20% testing. Okay, I am importing train test split and X train, X test, Y train, Y test, and I am saying that my test size is 30%. That means my training size automatically it's 70%. Okay, and random state nothing, like whenever you will run the code, those numbers will come to the training and the fixed numbers will come to the test. Otherwise, every time if you run the train test split cell without giving the random state, the program is such that it will shuffle your data, then it will take the random 70%. So every time you will get a different number. You will get 70% and 30% division, but the numbers are different for different execution. Today you have executed, you have stored, tomorrow you want to execute, you will get 70% data, but nobody knows which 70% of data. So for that, you give random state. Any number you can give. There is no specific, you can give 10, 15, okay, whatever number you can give. Yeah. Okay, 20 nothing. I am printing after division. What's the data? It's there. I am printing that percentage of data is X train 70%, Y train 70%. Okay, what I am doing, I want to see that what all the columns are there in X train. Okay, age, experience, income, all this. Now you see there is no ID column, there is no zip code column, and there is no personal loan column. Okay. So your data EDA stops when you divide into X test and Y test. When you run this code, then your EDS ends here. Okay, now you are ready with the data set. What we have done, we have given a data set. Okay, then we divided, we checked for the hint, HIND, head, info, null, description. We checked with box plot. Okay, those things I will come. Then X, we divide the data set into our X and Y. X is the feature, Y is the dependent. Okay, the target value. We check how they are related to each other and we split those data. Okay. Now it's ready. We want to build the logistic regression. Model building is very much easy, guys. The problem, the effort you have to put, I'm telling again and again, finding EDA. Okay, EDA is all the decision you have to take as a data scientist or a project manager, how you are going to do your EDA, which columns are important for us, which columns you want to give in the training. Okay, those stuffs. Your client will give you only this data set like this, and it will ask you to build a model for you. Okay, where he wants to check the personal loan selling. Building model is very, very easy. Okay, from a sklearn linear model, import logistic regression. I am importing here. Then I am creating an object, nothing. You can give your alias name, any name, and you this whatever you have imported with a braces. Okay, that's it. You have created LR object. Now you fit it, X train, Y train. This is common for all models. Okay, you import, you create an object, and you fit X train, Y train. Okay, once I run it, I will get output like this. I am this warning, nothing you can ignore until unless you are getting error. Okay, once it is executed, that means your model is ready. Okay, you have done LR fit. Now it's time to do the LR predict. The concept is you are training your model, building your model with the train set, and you want to test it with the test set. Okay, so while building, it takes X train and Y train. In testing, you give X test. Okay, you are giving X features. You want the model to predict Y for you. Okay, so this is the Y pred you are building. Means you are predicting LR.predict. From where you want to predict? X test. You want to predict Y. Why you want to predict Y? Because you have already Y test, right? Which is the actual value. You have divided into Y test. Now with the model, you are getting Y prediction, so that you can check like what's the accuracy of the model, what's the recall, how your model is performing, because you have actual data for you as a Y test, and you are predicting Y pred, so that you can check with the actual. Okay, so you are predicting with the X test. Logistic regression is a probabilistic output. We'll see first Y pred. What's there in Y pred? Print Y underscore pred. Okay, so it is giving that 0001 like that, or first for the first record it's predicting 0, for the second one 0, like that. For some it's 1, it's predicting. But how this prediction comes? Logistic regression is a probability output. Okay, so I want to check the probability. If you see, the function is called lr.predict. Till this point we have got it. Underscore proba stand for probability. Okay, now I will give print command C, control V. You see here, for the first one it is e to the power minus 01, right? Then you have to put the decimal to the left, that is 0.99. For the second output it is 0.66. The third output it is 0.96, like that. So by default, wherever it's more than 0.5, we have taken it as 1. Wherever the it is less than 0.5, we have taken it as 0. That's why the 0, 1 output has come. This is not in the same fashion. Don't think like here it is 0.9. How come it's 0 has come here? They are not into the respective record. But I just want to show you that this predict underscore proba, okay, predict underscore proba function will give you the probability output. So from that probability, the package has done it. Wherever it's more than 0.5, it's 1. Wherever less than 0.5, it's 0. Okay, if you see the right one here, okay, what's the probability? It's 0.0002. You have to shift the decimal left to the 4, right? Because it's e to the power minus 4. Then obviously for this output the value should be 0. It is less than 0.5. It's 0, 1. Likewise it will be predict 0, predict 1. If you see, this is the actual 0, actual 1, predict 0, predict 1. Okay, so your true negative is 132.27, because you are actually it's 0, you have predicted 0. Actual is 1 and predicted 1 is 97. That means true positive. Falsely predicted positive, that is false positive 16, because actually 0, you have predicted 1. This one is falsely predicted negative. Actual it's 1, you predicted 0. So you predicted negative falsely. Only whatever the matrix you will import here, like accuracy score, recall score, you give your Y test and Y pred. Y test is the actual value you have to pass, that it's there with you from the train test split, and Y pred is what model has predicted. Okay, so you see the accuracy of the model is around 94.9%. Okay. Likewise, the recall score is around 61.7%. Recall will never be more than 70-75%. Okay. So don't worry, it will not be in the 90% ever for any of the model. Accuracy will be 90 to 100%, and recall is around 60 to 70%. You will get it. Okay. What's the inference? Accuracy score of 95% implies that it is a good model to predict the likelihood of liability, customers buying the personal loan. Okay. It's predicting with 95% accuracy. But along the accuracy score, measuring the recall score is inevitable here to know the performance of the model on predicting positive outcomes for the given data. That how out of the terrorist, how many are actually your model is predicting the terrorist, because most people are civilians. So like this, it's saying we have to predict. Most people may say no, why will you take the personal loan? But for the model building, you have to focus like out of those interested, how much your model is accurately predicting. That's the recall. Okay, that ROC AUC score, you leave it as for now. These things you can get it in sklearn. You Google sklearn library, you will get it, or you search it in the Google how to import KNN. They will give you this one. So no need to remember anything. That's what I wanted to tell you. Imported the z-score from SciPy. SciPy is another library like sklearn. Stats stand for statistics, and I have given the entire x to that one, x dot apply z-score, and I have given another variable name xcalt. Okay, it's nothing like when there are different values in the data set, like it's a weight data set, someone in kilometers, some features are in meter, okay, centimeter, then you have to apply the z-score to make it normalized, to bring it into the one level. Only it's a simple function. You import z-square and you apply it, okay, with a function called, where you want to apply that name, x or y or your data, wherever, what's the name that you mention, and apply z-score. Okay, so there is no need to do manually anything. You no need to calculate, go for the standard deviation, do all these things. You just import z-square, put it, the package will do the work for you. Now I am ready with my x and y. Why I have not scaled y? Because if you scaled y, then you have to reverse it again. Otherwise, you will not understand the relation between the y pred and y actual. Okay, so I am giving my x score. All these features means I have changed it to z score between -1 to 1. Okay, if you want to see here, what I will do, I will show you the x scaled, how it looks. Okay, if you see here, I x scaled, right? Scaled dot head. Okay, now you see all your features is experience, okay, everything in a similar range, okay, around -1 to 1, but you see securities are around 2 to -1. It depends on the package. Wherever it wants to divide, it will divide, and it will produce a result and the numbers which are more close to each other. So that's why we apply z-score. Okay, now come to the train test split. Okay, here I have given random stat equal to 4. You can give anything. Now I am dividing data into 70-30. 70% into the train test, 30% is to the test set. Okay, I'm x train 1, x test 1, y train 1, y test 1. Why 1? Because already I'm writing the function in the same page, so that's why already I'm having x test earlier, so I put x test 1, x train 1, like that. Okay, you see line number 37. That's what I was telling you since yesterday. You need to pass only 2 arguments. Okay, KNN Once you build import, you have to build the object, right? Like linear regression. Here you have built LR equal to logistic regression, this line. Okay, like this in the KNN. Here you have KNN equal to K neighbors classifier. It's the braces. In braces you have passed. Otherwise, in what you can do, you can simply create here, and next one also you can pass it. So what you have passed it, n neighbors equal to 5. That is, n neighbors is nothing but your k value. Okay, you are asking to build the model with the 5 nearest neighbor. Okay, and weights is equal to distance. So you have to pass the distance, okay, and neighbors. Then you fit it with the X train Y train. Okay, means it will generate once you fit the model with the X train Y train, the model will be trained and you will get a output like this. Now come to your model has been built. Now do only Y pred. How will you do? Whatever your the object value where you have fit it, the same thing you predict it. KNN with which we will predict X test 1, because here it is your X test 1, right? Predict with the X test 1. Okay, the same you will get a predict probability and you will get a KNN score. Okay, like the logistic regression, the same thing. Now import the confusion matrix accuracy score, recall score, and check the accuracy score giving your Y test and Y pred. Now accuracy here is 96%, recall is 62%. Okay.